Okay. Good morning, all. Today's class is going to be on Docker. So, this complete Docker we have divided into two parts. First part is going to be Docker 1, and second part is going to be on Docker 2. Let's see what are the things we are going to understand and get to know in Docker 1. Okay. So, these are the agendas for Docker 1. Initially, we will be seeing what is virtualization, and then what is containerization, and then we'll be seeing what are the containerization tools available in the market, and then we'll be seeing what are the components of Docker. Okay. After that, we will be straightly jumping into hands-on. We'll be seeing installation of Docker, and then we'll be working on Docker commands. There are certain Docker command which you definitely need to know as a DevOps engineer. So we'll be working on all those Docker command, and then we will be creating a Docker Hub account. The similar way how we created GitHub account, we will be creating Docker Hub account in hub.docker.com, and then at last we will be seeing about Docker file. This is very crucial part of the Docker 1 course. So Docker file is very much important. Okay, even you will have many questions in interview as well. So let's start for the session. So before seeing what is virtualization, what is a virtual machine, before that we should know what is a physical server. You might have heard many times, right? People may be saying physical server. At the same time, people may be saying virtual server and then containers. So these are many kind of jargons you might have heard here and there around you, or else in the market, or else in the newspaper, TV. In this IT circle, you might have heard this. So initially, physical server means a physical computer is called as a physical server. Okay, so usually what are the parts of the physical servers, or else a computer? What are the hardware components of the physical server? Definitely, we will be having a CPU, and then cooling fans, memory devices will be there, like RAM, and then we will be having LAN port. We will be having fiber optics cable port board. We will be having, and then we will be having a power unit, and then sometimes we will be having a write controller to control the hard drives. Okay, usually these are the parts of a physical server, right? Even these parts will be present in your laptop as well. If you like open the back case of your laptop, you can see all this part in your laptop as well. But in case of server, when we go to physical server, all this part will be in a much higher grade. Meaning is that we will be having much higher configurations of all these parts, and there is no need to get into detail about this part. Just I want to give you an overview how the physical server usually will look. That is why we are having the slide. So now you got an idea about physical server, right? Only we know about physical server, then we can differentiate between the physical server and the virtual server. Later on we can differentiate about between what is a virtual machine and container. Okay, so you have any doubt on this part? Hopefully I think you will not be having. So this is a very basic thing. So let's see what are the problems we faced before virtualization. Meaning is that what are the problems we faced when most of the people they were using physical servers in the market in the IT industry. Okay, so usually the physical servers are very expensive. They are very expensive in cost. At the same time, to initialize the project, before initializing the project, you need the servers. So you need to order the server. You need to wait for many days for the vendor to deliver the server. After the server has been delivered, you should deploy the resources to assemble the server. So lot of background activities to be performed to set up a data center. Um, of- like data center means many servers to put together. It is called as data center. Okay, so the initial cost is very high because the servers are very expensive. Okay, at the same time, the resources were not being utilized at their fullest potential. So what is happening is that in case of physical server, let us assume you have a RAM for 8 GB, and if at all you are not utilizing, you are not in position to utilize the full 8 GB RAM. Okay, at the same time, another of your friend, maybe your colleague, he also needs a laptop. of 8 GB. You cannot share with him, right? It's not possible because this physical server is solely meant for you. At a time, only one person can use it. So if another person also needs a laptop, he need we need to give him another laptop, even though you are not utilizing the laptop to the fullest. So it is not possible to share with them. I'm not like speaking about physically sharing. You cannot virtually share with them, right? The physical device can be used only one to one. Okay, if at all another person needs a same configuration of a laptop, even though he may also utilizing the laptop very less, but it is a necessity that he himself also needs a laptop. That is what, even though you are not utilizing the resources fully, it is not possible to share the resources between the applications. Okay, and then the next point says the process of getting any software update and running was very time consuming. Always you might have heard that physical machines, that is the um, physical servers, they will be usually very slow. At the same time, it will take lot of time for updating software and get the system up to date. Okay, and disaster recovery is also very difficult. So what is disaster recovery? So usually when there is a, maybe you might have heard, there is a tornado in South US, in North US there is a kind of heavy rain or heavy snow, sleets. In case of India, you might have seen lot of floods, tsunamis. Okay, if this kind of natural disaster, if it is hitting the particular data center, it is very difficult to recover the physical servers. Okay, that is why, like, these are the disadvantages people were facing before virtualization came in, when people were using physical machines, that is physical servers. Okay, so then after that people realized that we are facing many actually hiccups when it comes to physical server, so they came with an idea called as virtual machines. So what is a virtual machine? Usually virtual machine also, it is actually hosted on a physical server only, but here you will be seeing the difference. Basically there will be a hardware host. Usually what people will be doing is that they will be buying a server. Okay, over that server they will be installing the host operating system. Okay, over that what they will do means they will be installing something called as hypervisor. This hypervisor will make this the underlying hardware host in a such a manner that you can build multiple servers from this hypervisors. But in case of physical server, if there is a hardware host, you can build only one operating system, or else you can build only one server over it. But in case of virtual machine, what is happening is that basically you have the host hardware over that host operating system is installed, or that we are installing something called as hypervisor. This is the main and critical part of a virtual machine. This is the component which made actually a world of difference. Over this hypervisor you can build as much as VM machine you can. It's like as much as VM machine the host hardware is supporting, we can build. So in this example you can see we actually three VM machine they have built. So over the VM machine, they have hosted application. And again here they have built a VM machine, and then over that they have built application. Here also they have built a VM machine, and then they have build a like they have hosted application here. So what is the difference is that in case of physical server you can build only one server, that is you can install only one OS over that, and over that you can install only one application, you can host only one application. But here in case of this virtual machine, see, you can install multiple OS according to the space availability and other hardware constraints. You can build multiple OS. Over that you can install the applications as well, you can host the application. So what we can do is that, let us assume this is a kind of a physical machine. Over that an hypervisor is installed. Here the company requirement is, suppose your project requirement is two Linux machine, that is two RHL servers and one Windows server. Okay, but in case of physical machine, what you can what is the only possibility is that you should buy three physical servers, and you should install one over the Linux machine, and another physical server you should install a Linux machine, and third server you should install Windows. But here, in case of virtual machine, what you can do is over the hypervisor for this particular in VM1 you can build a Linux machine, and VM2 also you can build a Linux machine, and here you can build a Windows machine. Okay, you can build a, what I'm trying to say is that you can build multiple flavors of operating system. But when you log into this particular VM machine, VM1, you will be feeling as if you are logging into a individual machine. You will not feel anything different that you are logging into a shared resource. Okay, so this brought a great revolution in the market where people started using VM machine. Even nowadays, actually, we are creating or else we are launching instances in AWS, right? So those instances are generally they are VMs. They are not like physical machine, they are virtual machines. Got it? So this is all about virtual machines. Then let's see what are the advantages. What are the advantages we came across after virtualization? So the cost of spending in hardware reduced there very drastically. Why? Because means over a single physical OS, you can build the necessary or else required VM servers, right? So this has completely reduced the cost of spending, and then resource utilization is greater. Why? Because means a single physical machine over that you are actually building many virtual servers, so you are at most utilizing the resources, like resources in the sense you are utilizing the hardware, CPU, RAM, memory, and then hard disk, and then we will be having network adapters. Okay, so all this kind of components you are utilizing to utmost, and at the same time server speed is also very high because of something called hypervisor. So this is a kind of software, as I already told, it will be increasing the server speed, and it will make the server as more agile one. So you will be like so you will be feeling something like it will be like thundering speed. Okay, and then high reliability with backup and disaster management. Why? Because like it is having high reliability with backup and disaster management is that there is a chance easily, since it is a VM machine, you can have a copy in many regions of the world. Okay, so there is no necessity that like in case of physical machines, it's physically present in some location. So if suppose the Chennai data center got affected by some kind of flood, so there is a chance that all of your data might have got lost. But in case of VM machine, what people will be usually doing is that using our hypervisors and other kind of virtualization technology, they will be having a similar copy in other region as well. So they will be having a data center in Mumbai. At the same time, they will be having a data center in Chennai as well. So if at all the Chennai data center got fully affected, what they will be doing is that they will be like bringing up the servers which are hosted in Mumbai data center, so that your data will not be lost at any cost. Got it? So these are the advantages of virtualization. So now we are now we are into the era of containers. Okay. So what is a container? So to understand in a better way what is a container, so now I have took up an example of a seed ball. You might have heard, right? Seed ball. Have you heard about seed ball? Any of you? Nirmal or Bindu? Have you came across this terminology called seed ball? Okay. So let me explain it. What is a seed ball? So usually you might have seen many government projects, right? People, government will be actually they will be framing many project. You might have came across a project called where they want to plant these many trees in our country for the upcoming year, maybe upcoming 5 years. They might have a project of we need to plant 10 crore trees. So at the same time, there will be some locations like deep foresters where the human cannot go himself. Okay, so this kind of deep forest, there is a chance that you might have heard something called forest fire, right? This forest fire, what it will do means, usually it will destroy completely the. Actually, it will destroy the major part of the forest. You might have heard this kind of things happened in southern Tamil Nadu, Western Ghats. Okay, in case of all over the world, you can take the example of Amazon forest, which is a part of South America, where usually you will get this kind of forest fire. So all this kind of forest fire, it will destroy the forest, and it will reduce the green cover of the forest. So in that case, if it is a roadside area, or else it is within the city, or else it is within the panchayat or taluk, what people they will do is they will they will be having a team, and then they can plant the tree by themselves. Okay, the Chennai corporation or else a particular panchayat, they will plant the tree. But in case of forest, you cannot plant a tree like that. Okay, because it is like it is not accessible by humans. So like we have like some kind of technique called seed ball. What they will be doing is that they will be actually they will be putting the seed inside a ball of sand. This is not only a sand, this is a kind of all kind of nutritions, okay, and all kind of necessary things which is needed for a seed to sprout and go into a plant. It will be kept under this balls. Okay, so inside center of this ball, a seed will be kept, and then they will be putting it into, or actually they will be making it into a round fashion. So usually this is a kind of like kind of manure only. Okay, so they will be putting it in a round fashion, and then they will be drying it. After that, what they will be doing is that, maybe in helicopter, they will be reaching that remote area, and then from the helicopter they will be trying to spread this. Okay, so once this shield ball lands actually into the forest, once it gets enough water, it will start to the seed inside the ball, it will start to sprout. Okay, and then it will become a tree. So in similar way, here the seed, what like what we are calling it as seed, you can take it as a code. Okay, the source code which the developer is actually developing. Okay, so to code to actually the code to become a end product, the code to become application, it needs certain kind of environment, right, to become application. So this application will be created by the container. So you should take the seed as a code. Okay, the source code, and the seed ball you should take it as a container. So how the seed is growing, right? It is getting all the nourishment from the seed ball in a similar way. So what are the dependencies needed? What are the dependency software needed? Okay. So and then what are the ports needs to be what opened? So there are many things for an application to get launched successfully. So all these kind of things will be taken care by the container. Got it? So let us assume you are having a source code, but the source code should be only this code can run functionally. It can run and it can get deployed only in RHEL server. So the main dependent is RHEL server, and then this code is a Java code. Then you need a Java package. So the second requirement is Java package, and third thing is you need even a Python package as well. So you need a Python package, and then they are having like they are introducing certain kind of search boost in it. So let us assume they need some packages related to elasticsearch. So like this, these are the minimum requirement which are required for the application to get deployed. So all this kind of dependency packages will be wrapped inside the container, and the code will be kept inside the container, and then it will be deployed in the particular server. Got it? Now you understood what is a container. It's clear for you guys. So only if you clear in the stage, we can move to maybe in the next part. Clear, right? So let us technically see what is a container. Here you have seen, right? Virtual machine, you are seeing a hardware and then operating system, hypervisor. Over that, you are seeing individual virtual machines. In similar way, what you can do is that how in a particular physical server you can build multiple VMs. In similar way, in a single VM, you can create multiple containers. Okay, so let us take an example. Now we are creating an instance in the AWS, right? We are creating Ubuntu instance. That is a VM machine. In that particular VM machine, you can create many containers according to the hardware capability. You can create multiple containers. Okay, so how this container will be actually running over the VM machine is that, so initially we have the infrastructure. Over that we have the operating system. In our case, our operating system will be Ubuntu operating system. Over the Ubuntu operating system, what will happen is that we will be having a container engine. Over the container engine you can actually build multiple application, meaning is that you can create multiple containers. So this container engine is nothing but installing a Docker is called as container engine. The Docker package which you are going to install in the virtual machine, it is called as container engine. Over the container engine you can create multiple applications, you can create multiple containers. Okay, now you understood, right, what is a container. So you can see this example as well. This actually this definition as well. Containerization is a software deployment process that bundles application code with all files and libraries it needs to run on an infrastructure. So whatever I have explained, they have given in a short and crispy manner as a definition. Okay, so this is called as containerization, or else you can call it as virtual containerization. And then what are the problems we faced before containerization? When VM machines were there, when applications were directly deployed in VM machines, what are the problems we faced? VMs are usually huge in size. One actually just to install one VM, it will take 2.5 to 3 GB in size. Okay. At the same time, they are not developer friendly. Why? Because to operate a virtual machine, the particular developer he should have the knowledge of a system administrator. So it is not possible for the developer to have the complete knowledge of the system administrator, because its job is to only to develop the code, right? So that is why it is not developer friendly. But at the same time, VM are bit costlier. See, when compared to physical machines, VMs are cheaper. Okay, when compared to VMs, containers are much cheaper. Okay, so that is why we will be like that is why like how humans will be evolving, right? Initially you may be spending more, then you will reduce your expense to certain extent. After some day you will be feeling even that spending that much itself it's more, and then again you will be reducing your expense. That is how the budget of a company or a budget of a country as well it grows, right? That is why that is how it works. Similar way, so containers are much cheaper when compared to virtual machine. At the same time, it is very easy for a developer to create a container with a Docker file. Easily, you can create a container. So let's see. Okay. So you already this example I might have shown in like previous classes. Anyhow, I will explain you again. So usually what it was happening before container like came into picture, when virtual machine was there, when people used to deploy the application straight away in virtual machine, what it will happen means developer you will write a code and you will be feeling everything is working fine in his in his local laptop. But when he gives the code to the to the ops engineer, the code is usually the code will not run fine, because the code needs many dependencies, packages and libraries to make the code to deploy successfully. So all these dependencies and libraries may be present in developers local laptop, but it will not be there in ops engineers real-time server. So that is why this issue was there. Once this containerization came, so that so what the developer will do means he will list out all the required libraries and packages in the Docker file. So once he build the Docker file, so Docker file will be come along with all the necessary libraries and packages and along with the source code, so that it can be deployed in the in the end server. Got it? And then how did this is what we are speaking before. How did containerization solve the problem? With containers, all the environment issues were solved. Environment issues means, so a certain kind of thing may be working in your laptop. It may not be working in my laptop. Meaning is that, what is the meaning? If it is working in your laptop and if it is not working in my laptop, means the setup is different, right? The in the environment is different. The packages in your software may be like in your laptop may be different, and the same packages in my laptop may be different. Packages, hardware, and then kind of other dependencies may be different. That is why it may not be working. But this container is a thing where the whatever dependency needed, the developer he will be wrapping it, and then he will be giving that the complete list to the operations engineer, so that it will be working as expected by the developer. Got it? And these are the advantages. Containers are very lightweight. Guys, you will not believe a container will not be more than 70 MB, 70, 80 MB only a fresh image of a container. If you are just pulling a Ubuntu image, yeah, and you are like installing the image in a any kind of virtual machine, it will take you around 3 GB. 2.5 to 3 GB, but a container, the same Ubuntu container, it will be less than that. It will be like only something around 70 MB. Why? Because means a container will not download all the libraries and all the binaries files required for the Ubuntu. It will download only necessary files which is needed to run the container. Got it? So whichever thing is necessary only it will be having. If you need something necessary, you should install it. That's it. So it will reduce the weight of a operating system. So it is very, very lightweight, and they are developer friendly. Why? Because means there is no need that developer should actually should have a lot of knowledge on system administration. If he knows how to build a Docker file, it's fine. Even though if he don't know to build a Docker file also, it is fine. You can just you will be giving only the requirement. What are the requirement needed for this particular code to run? What are the dependency packages? You will give the list. So as a DevOps engineer, we can write a Docker file and we can build the container over it by using the Docker file. And to and it, you will not believe, guys, it will take even a fraction of seconds. Within 1 or 2, like around 30 seconds, you can create a container. Just to create a VM virtual machine, it will take you around in AWS itself. It is taking around 4 to 5 minutes, right? Let us assume it is a cloud platform. You are creating a virtual machine in your own in-premises platform. It will take more than a half an hour and 1 hour. Okay, before maybe now also in many places this kind of resources may be there in many companies. We used to call somebody called we used to call somebody as build team. I don't think whether you might have heard this. People, we will be having a team called build team. Their main work is to build the server. Okay, one day in per day they will not be able to build more than 2 servers. We will be getting like kind of all requirement, and then they will be building the server from scratch. Every each and every part they will be having one detailed document. They will be following up that particular document, and then they will be building the server. Okay, but in today's case, we are building the server from AWS, so we are able to make it in less than 5 minutes. But these containers will be much faster because since they are very lightweight in manner, it is like you can create a container in a click of time. Okay, so these are the advantages of containers. And then we can see the evolution of the container. So initially there was a physical server, and then people thought this is like it is having a lot of hiccups and bottleneck. So they moved to virtual server, and now they are people are using containers. So they are using containers over the virtual servers only. But containers are the main things used to deploy all most of the applications. Even though if they are using Kubernetes also, indirectly Kubernetes is using Docker only. Okay, so Docker is using containers. Got it. So these are the evolution of containers. And then we can see what are the tools, what are the containerization tools available in the market. So Docker, it is a containerization tool. RKT is a containerization tool, and something called Mesos. This is a product of Apache. It is also a containerization tool. But Docker is very much famous in the market. Most of the corporate companies they are using Docker only for their application deployment. Okay, so Docker is a open source tool where you no need to pay for Docker straight away. You can download the package and you can use it. Got it? And then let us see what is Docker. Docker is a containerization tool. Already, as I explained, right? So let us give a reading on this definition. Docker is an open platform for deploying and running application in large scale. Docker enables you to separate your application from your infrastructure so you can deliver software quickly. So what this says, Docker enables you to separate your application from your infrastructure. Meaning is that infrastructure means the physical infrastructure, that is the CPU, RAM, okay, hard disk, and all other kind of network devices. So it is bringing a kind of um, um, a disengagement between this hardware and the application. So it is creating a kind of environment where the application is running in a very agile and a very speed manner, very lightweight manner. Got it? So this is all about Docker. This is a symbol of Docker. You might have seen in many places. So this explains means in if you install a Docker, you can you can deploy multiple container. That is what this picture shows. So here you can install, here you can deploy one application, here one application, here one application. Like that you can deploy multiple application. When containerization was not there, in a virtual machine you can deploy only one application. But now after Docker came into picture, after this kind of containerization technology came into picture, in one virtual machine you can host multiple applications. Got it? So let us see what are the Docker container life cycle, how it works, what are the life cycle. So life cycle means once you created the container, what are the steps like it involves around the container, and how the container life cycle is evolving. That is what we are going to see. Initially you are creating a container. After creating the container, you can start the container, that is you can run the container. After running the container, you have multiple options. You can pass the container, or else you can stop the container and again start the container, or else you can pass and unpass the container, or else if you are feeling that you no need the container, you can delete the container. Okay, and then again you can create the container. So it is a cycle. Okay, we will see command to do all these things guys. Okay, and then let's see what are the components of Docker ecosystem. So Docker ecosystem, in the sense, in the Docker environment, so what are the components we do have? The first one is Docker engine. Docker engine means the package which we are installing in the virtual machine. It is called as Docker engine. So that is a basic, that is a thin layer of containerization which will be added over the operating system in a virtual machine. Okay, which is called as Docker engine. Over that you will be pulling the images. To run a container you need an image of a particular operating system. So if you want Ubuntu, you can pull the Ubuntu, or else if you want any kind of database like MySQL database, or else a Mongo database, okay, or else any other kind of like Microsoft MySQL is there. So any kind of database if you need, you can pull that particular image, and then you can run a container also. It is a part of a ecosystem. And then volumes, so we will see volumes, all this Docker volume kind of stuff in Docker 2 session. Now, you just have in your mind, Docker volume means it is a kind of storage space. Okay, and then we have something called Docker file. So Docker file is a mechanism given by Docker where you can automate. Okay, where you can automate the building the Docker images. So all this kind of things, Docker images, containerization, initially we will be doing manually, how to pull the image and how to run a container, how to stop the container, all those kind of things we will be doing manually. So using Docker file, what you can do is that you can automate all the steps. You can do it with an automation. And we have something called Docker Hub. Docker Hub means whatever image or else whatever container image you are having in the local yeah, VMware machine, you can push it to a Docker Hub for your future references. Okay, let us assume you are having a container, so it is having all the setup for your particular application to run. What you can do is that you can save this container and you can push the container to the Docker Hub. So whenever needed, what you can do is you no need to create a container, and then you can like you no need to install the Apache 2 or else Tomcat in it. Directly you can pull the container, ready-made container from the Docker Hub. Got it? That is what called it as Docker Hub. Now we are into the phase of installing Docker. What I will do is I will go to AWS console. Let me log into AWS, and then let me sign into the console. I will give my credentials. Let me sign in. So I will go to EC2 instances. No instance is running because I have deleted all the previous ones. Let me launch an instance. I will say this instance as Docker instance, and I will select Ubuntu image, Ubuntu OS. Key pair I will select to Kubernetes learn, and then I will launch the instance. Once I have launched the instance, if we scroll down here, we can see orange button called View All Instance. I will click here. We can see it is in pending state. So let's wait for the instance to be in running state. Let us wait. So still here you have any doubt? Clear. Okay. So now the instance is running. But still the checking status it's showing initializing. Let us wait for a couple of minutes. So it is taking some time, right? Maybe 2 minutes or 3 minutes, something around that, right? You will see how the container, when we are creating container, it will not even take a fraction of a minute. Just like that you can create. So I hope it will be ready. Let me try to connect. Okay. So what I will do means initially this is a norm you should follow whenever you are creating a machine. Initially you should update the machine to the latest. Sudo apt get update. Okay. So our machine is updating to the latest. Yeah, it's updated. I will clear the screen. And now what I'm going to do is I'm going to install Docker. Sudo apt get install docker.io. This is a package name for the Docker to install. Okay, you should remember this package name. So the command is sudo apt-get install docker.io. I will hit enter. So it is asking you, do you want to continue? So it is giving an instruction. These are the packages. You are going to install. If you give yes, if you find you don't want to continue, give no. So I will give yes. Hit enter. So it is installing all the necessary packages needed for the Docker. So in exactly what it is doing is that it is building the Docker engine. So this Docker engine will be a layer above the operating system. That is above the Ubuntu operating system. Looks like it got installed. Let me clear the screen. I will say sudo service Docker status. I will be. Let me check whether the Docker service is running. So it is in a running state. Got it? So you can see active running means it is an active state. Okay, it is an active state. So to come out of this prompt, you should just press Q. It will come out of the prompt. Now what we can do is that let us check the version of a Docker. Docker hyphen version. Looks like we need to give double. So sudo docker hyphen version. Should give double hyphen. That is why it gave error. So Docker version. So this is the version of the Docker 20.10.21. I think this is the latest version. Let us check what is the latest version of Docker. Latest Docker version for Ubuntu as well. We can. So the for Ubuntu, the latest version it looks like 10.10. So what is the version we got here? 10.10, right? So we are using the latest version. But usually in real time scenario, people will not go for a latest version. They will be always using one version behind the latest version. Do you know why? Yeah, that is the main thing because anyhow, see, if a company is releasing a particular version means they have already they might have done R&D for all the operating system, and then only they are releasing. Even though people what they will be doing is that in corporate world they will not take up the latest version. They will take one version behind the latest version to be in safer side. So when people started using that, and then they will be coming up with lot of complaints. What are these are the complaints we are facing, and then again this Docker company they will work on it and they may be fixing it if at all there is an issue, so that nobody will be in a position to take a risk in case of application running an application. So usually they will be going for n minus one or n minus two. I would say it is better to go for n minus two. Okay, so we have seen Docker version. Now let us go back to the PPT. So we have installed Docker and we have seen the Docker service is running successfully, and we have updated the latest version of Docker. I have shown you. Okay, now let's see Docker hands-on. Okay, so we have installed the Docker. That is the first part is done, and then we have checked the status. We have checked the version. Okay, now what we will be doing is that let us try to pull a image. Okay, whenever if you try to pull the image usually it will be coming from the Docker hub. Okay, I will try to pull the image. What I will do means sudo Docker image pull. So what image I want? I want Ubuntu. Okay, so it is pulling. So it is saying using default tag latest. So it is trying to pull the latest Ubuntu images, and it is saying latest pulling from library Ubuntu. Directly it is pulling from the Ubuntu library, and it is saying pulling completed. Maybe this may be the um, this particular images ID, and digest it is saying the it is giving some kind of code. Digest means you heard about this thing SHA-256? What is this? Normal or Bindu? What is SHA-256 means? What is that? Image ID is here. This maybe this also you can take it as image ID. What is this? What does mean by SHA-256? Just you think on it. Maybe, and then it is showing the status downloaded newer image for Ubuntu latest image it is saying, and it is saying where is the latest image. It is saying it is under this particular path docker.io libraries. So under this library you are having this. So SHA means it's a kind of algorithm, encryption algorithm. So what it is trying to do is that it is checking the integrity of the package. Once the pull is completed, it is checking the integrity of the package, whether the package is looking as if how it is there in the Docker Hub. Okay. So in Docker Hub, the usually the package will be in a perfect manner, while pulling anything got like corrupted, anything got erased, or else anything is not working fine. So so SHA-256 it's a kind of algorithm kind of thing. So it will check whether before downloading and after downloading the package integrity is looking good. Okay, so whenever you are issuing any command, whatever output you are getting, just you if it is successful, you should not go, like you should not move on. Okay, as an engineer, just you should look at all those things. It will give you a kind of insight. Okay, so now we have pulled the image. How to find whether the image is pulled successfully? We should validate this right from our side. So there is a command called sudo docker images. This will list out all the images. So you can see here, right? This is the image. present. Whatever image we have pulled, it is here. Okay, now what we can do is we can run a container out of this image. So to find a running container, the command is sudo docker ps. It is not showing any result because we are so far no container we have run. And there is a command called sudo docker ps -a. Usually this sudo docker ps command, it will show only the running container. If you give -a, it will give it will be showing all the containers, both running and then stopped containers. It will be listing out all the containers. So here also usually the as expected, the result is no. Okay, now let us try to run a container. Sudo docker container run -it. These are the flags you should use. -d, -name. What name shall we give to the container? Suggest a name, like your first container. Suggest some name. Ubuntu one. What man? You should give some fancy name, right? Ubuntu. And then you should give the image name. So sudo docker container run the container -it -d name. Name of the container is Ubuntu one. That is what Nirmala suggested. And then you should give the image name. Image name is already we have downloaded Ubuntu image, right? So we should give the image name. I think this may confuse Bindu. So I will give the name as Bindu only. So now the container name is Bindu, image name is Ubuntu. Hit enter. See, just a fraction of second it created. The the time I like entered the like hit the enter button and we got the this particular ID is same. So this much time only it will take to create a container. So let us see the container sudo docker ps. What are the processes running? See, the name of the container is Bindu. So and then it is saying that this is a container ID, and then image name is Ubuntu, and then actually leave this. What they are saying is that whatever command you are typing, so it is from this particular path. So whatever command you are typing, behind that command there should be a script, right? So all this kind of script should be behind this. And then it is saying created 25 seconds ago it is created, and status up 25 seconds, meaning is that before 25 seconds it is created, now it is up and running for 24 seconds. If you again give, it will show so like more time. So it is saying about a minute ago, so it crossed 60 seconds, so it is saying about a minute ago and up about a minute. So we have created a container. Now how to enter inside a container? Now we are inside a VM machine. This is the container. How to enter inside the container? We have a command sudo docker exec, means execute inside a container -it, and then you can give a image name or else container name. Image name means container ID. Sorry, container ID, not image name. Sorry for that. Either container ID or else container name. So I will try to give the container name only because that is easy, right? I no need to copy that window, and then I need the and then I'm saying the prompt should be a bash prompt, the command prompt, so that I can execute some command. So bash. Hit enter. See, you can see, right? Here you are inside Ubuntu. Immediately jump into that container. How to validate? This is a container ID, right? 8B0D8008C1327. Okay. So how many digit is that? 2, 4, 6, 8, 10, 12. So usually the container ID actually consists of many digits. Okay, when you give sudo docker ps, it will show only the first 12 digits. So it is fine. Now you are inside the container. Okay. Now what I will do is that how to exit from this container? Exit. Just exit it. Now again I will enter this container using container ID. Let's see how to do that. Sudo docker execute, that is get inside the container -it. container ID. I will copy this container ID and I will paste here. And then I will say bash. Also, you will be able to enter. See, you got entered into container. So here you will be, if you give LL means long listing, right? It's showing, uh, and then if I'm creating, let us create a folder, mkdir, and I will say container app folder, app got created, and then I'm entering into app folder. I'm inside app folder. Let me create a file. I will say example index.html. It is saying VM command not found. Why? Because means this particular container, it will have only basic necessary thing that is needed for the container to run. Only basic necessary libraries and binaries will be there. If you want to even a simple see, if I give sudo and if I say kind of mkdir and if I say um, demo kind of thing, it is saying sudo command not found. So you can see, right, this sudo means it's a very basic command. So sudo means to get the privilege of root. That is the meaning of sudo, right? Sudo is a very basic command. Even that command is also not there. So actually, to put all this command is the why I'm issuing all this command in the container is that to make you, or else to make you understand that the container will come only with the basic libraries and binaries needed. That is why it is very light in size. Got it? So now we will exit the container. What I will do means sudo docker images. See the size of the image. This is the size of the container image. Only 77.88 MB. What is the size of Ubuntu image? Let us check. Ubuntu image size. Usually, see what is the size people are saying. They are giving this for Docker size, I guess. How to increase the size of the or VM? See, this is saying maximum, minimum 25 GB. Installing Ubuntu on Ubuntu solution 512 MB. So they have bisectioning. It's totally usually it will come around 3 to 4 GB. But now here we are using the Ubuntu images as a container. It is very 70. It is only 77 MB. So this total size of this operating system itself, the image, the core image of the operating system itself, 3 MB. Now if I give lsblk, so we have around how many GB? Size df-h. Let's see mounted file system size. Root file system itself, it is around 7.6 GB and available is 7.4. At least I think, at least you can create minimum 100 containers in this operating system. We have that much space. Even though we did not add any new disk, just this is a fresh server we are using from AWS, right? And now what I will do is sudo docker ps. So this container I will try to stop the container. Sudo docker and then container name stop and then container name. So it is taking some time, right? Because it's a running container. Immediately it cannot stop. So it will be initially stopping all the services and then it will stop the container. So it is showing the container name. Now if you give sudo docker ps, it will not show because we have stopped the container, right? The ps command, it will show only the running container. If I give hyphen a, it will show hyphen a will show all the container. So it is saying status. Before it was showing the status as up 7 minutes. Now it is showing the status of exited, meaning is that the container is stop. Okay, let us start the container. Okay, what I will do is sudo docker windows the container. So I need to start, right? Sudo docker start window. So now again, if I see sudo docker ps, it will show. Now it will show up 6 seconds. Now, let us assume suddenly there is an issue with an application, like you are getting an instruction to immediately stop the container for some reason. Like you want to bring down the application for some reason. Maybe you are upgrading the application, so you need a downtime. So like you are getting an instruction from your senior to bring down the container. So if you give stop command sudo docker stop container, if it is a big application, it will take more time to bring down the container. So in that case, what you can do is sudo docker kill, sorry bindu, so immediately got killed. If I say sudo docker ps, it is not going to show any of. If I give -a, it will show. So you found the difference, right? When we are stopping, it is taking a bit of time. Meaning is that it will be gracefully stopping the container. Gracefully means it will be properly stopping. What are the services need to be stopped? Step by step, it will stop all the process and then it will stop the container. But if you give kill, immediately it will stop the container. Even this command, you should not use it in real-time environment. You should not kill a container. It's not advisable to do that. But you should know this command, right? You should know how to stop it as well. So let me start it again. Sudo docker start. Undo. So she got started. I give a see running up 3 minutes. Now what I'm going to do is that sudo docker ps. I'm going to remove this container completely. Sudo docker rm, and then I will say undo. Whether this will remove or not. What is your assumption? Nirmal, whether this command will remove the container? This will not remove. Why? Because means, so there is a chance that by mistakenly an engineer can delete a container, right? So it is saying error response from daemon. What is a daemon? Let us see what is a daemon. Initially, we'll like I will read this particular error. Error response from daemon. You cannot remove a running container, and it is giving the container ID. Stop the container before attempting removal or force removal. So it is saying it is not advisable to run a to stop to delete a running container, right? If a container is running, means it is running for some purpose. So it is saying no, you should not do this. First stop it and then kill it and then maybe remove it. So what is daemon? Daemon means some kind of process which is running in background. It is called as daemon. Certain processes will be running in a foreground in a machine, in a virtual machine, or else in case of any engine. Here in case of Docker engine, a daemon means a kind of process which is running background. Okay, so what you can do is you can stop and then you can kill it. Sudo docker stop the container name. Stop. Either you can give the container name or else you can give the ID. So it will take some time. Since we have given a stop command, it will take some time. Gracefully it will stop. It got stopped. Now what I will do is sudo docker rm, and then I will give the docker name, the container name. See, it removed instantly. It removed. Sudo docker ps-a also, it is not going to come. So again, let us try to launch another container. Sudo docker, okay, uh, container run hyphen it hyphen d hyphen name. We can call this container as mm, marvel. And then one image name is Ubuntu because we have only one image downloaded, right? Ubuntu. So this container is running. If I give sudo docker ps, we can see the image is running. Now I want to delete this container. Directly I want to delete without stopping. What I can do is sudo docker rm hyphen f. Hyphen f means forcefully remove. Don't give me any reason. Simply remove. If I give marvel, hit enter, it will not show any error. Straight away it will remove. If I give sudo docker ps, it will not show any container image. If I give hyphen a also, it is not going to show. Got it? Sudo docker images. So this particular image is there. How to remove this image? Sudo docker. To remove the container, we used rm command, right? To remove the images, we should use sudo docker rmi. Remove image and then image name Ubuntu. Hit enter. Got deleted. Now clear the screen and check sudo docker images. No images. Got it? Now what I will do is I will again pull the image. Sudo docker image pull Ubuntu. I will pull Ubuntu image only because that is easy to do. So the image is pulled and then sudo docker images. Now we can see the image. I will run a container over this image. Sudo docker container run hyphen it hyphen d. Okay, and then hyphen p. I will give a port number. So what I'm going to do is that inside this particular container, I am going to put a small application and we are going to see this application. We are going to launch this application via this Docker container. So I'm going to map this container with the port. So what I'm going to say is 82. 82, it is a port number of this particular virtual machine. This virtual machine port number 82, I am mapping to 80. Usually what is the port number 80? Port number 80 is for Apache. Apache web server. Some people used to call it as middleware, but the correct way is web server. Apache or HTTPS. HTTPS different. It is actually 403, and we have many other port numbers as well for HTTPS. For Apache, it is 80. Okay, and the name 8080. What is then for Jenkins? Let us see. Okay, yeah, let us see. So hyphen name, and then let us give this particular container as web app, meaning is that web application, and then the image name is Ubuntu. Okay, let me click enter. So this is running. So what I will do is sudo docker ps. See, as an engineer, always you should validate your action. Whatever you have did, you should validate it. So I'm validating. Now I am seeing it is running, right? So I will try to get into the container. Sudo docker exec hyphen it web app. Got it? And then bash. I'm inside the container. Now what I will do means I will install Apache 2 in inside this container, and then I will create a small website for you guys. Okay, apt. You see inside container you no need to give sudo. Why? Because means already you are a root, so no need to give sudo. Apt hyphen get install. I'm giving hyphen y. Usually when I install Docker, I do not give hyphen y. If you give hyphen y flag here, what actually it will happen means it will not ask for you whether I should install or else I should not install. It will not ask for yes or no. Straight away it will install. So I am very pretty much sure that I need to install Apache. So Apache 2. So I'm giving hyphen y. Apache 2. Apache 2. This is spelling. Let us see. Maybe what is a. Let me see the package name. Just a minute. No, no. The thing is that why it's not working is that initially we should update the machine. apt get update. Now after that it will work because it needs certain kind of minimum libraries, right? It will not be having since it is a container. It will not be having. Now it will work. No, 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 no. It gone. Completed. Uh, Let us install Apache 2 now. apt get install Apache 2. Now it is installing. It is asking me why yes or no because I did not give hyphen y. I will say no. Again, I will issue the previous command saying that hyphen y. Don't ask me. Simply install. Yeah. So for Apache 2 and HTTP, the port number is 80 only as I suspected. And for HTTPS, the port number is 443. And for Jenkins, it's 8080. You got confused. Come on. Sorry. Nirmal. Okay, we installed Apache 2. Let us see the service status. Service Apache 2 status not running. It's our bad luck. So let us start the service. Start the service again. Let me check the status. It is running. Now what I will do means we created the server already, right? We are running the container inside the server only, but I have not configured security groups. What I will do means I will click the server name and go to securities. Under securities there is something called security groups. I will go there. We will find a button like edit inbound rules. Click the button and there will be a button called add rules. Here whenever you are doing practice till you are completing the course, but you should not do this practice in your maybe real-time environment since like you should not have any interference in your course of this time. So give all traffic means you are opening all the port to entire world. Okay, so I will say anywhere ip for ipv4 it's enough. I will save this rule. Okay, and then I will go to instances and then click the docker particular server. Here you will be seeing the public IP. Copy this public IP, go to the next screen, paste the IP, give colon, and then port number 82. Because the port number 82 of the server is mapped to port number 80 of the container. Port number 80 is for Apache 2. So if you just hit this particular port, you will be able to see the installed Apache. You are able to see, right? So, so it is showing you that we have installed Apache in the container level. Now what I will do is that I will stop the container. I stop the container. I will put you the status as well. It will show, it is showing Apache 2 is not running. So again I will go here and refresh. See, it is saying this site cannot be reached because Apache is down. So now it is just Apache, the web server. In this similar way only application will be also launched. Okay. Now what I will do means again I will go and start the container. Start. What started? I go and refresh here. See, we're getting the container. Okay. Now what we can do is that in similar way we can write a small HTTP code, that is HTML code. Okay. Sample HTML. If you are very like lazy to write the code, what you can do means you can follow my steps. You can steal the code from here. Got it? I will steal this code. I will go to the container. Now we are inside the container, right? What I will do means usually all the applications file will be kept under this path only, slash var www html. So whatever you are getting the output here, right? This one. This page is because of this particular file, index.html file. Okay. Now I'm going to create another index.html file, maybe with a different name, and then we are going to map it to the application. Okay. So what I will do means, if I do vi index one dot html, what it will do anyhow, it will show the error only. So I will install vm vi. Okay. apt hyphen get install hyphen y. I will say vim. Vim is the package name for vi editor. It will start install. We install this. Installation is successful. We are inside the container only. Now let us go inside this. I will copy this code. I will make my own changes. I will say as learn first para. I will say software training and placement. Okay. Now what I will do means I will go here. Here you can see the Apache thing, right? But our particular application, our small website, it is inside ht, it is not index.html, it is index1.html, right? So I will give the file name index1.html. See, we got the website. Got it? This is how instantly you can write a like you can launch a website, you can deploy a website using containers. You got it, guys? Now I'm going to show you another example where in same virtual machine we are going to launch another container with another container. Okay. And we are going to host some other application. I will take inspiration from some other thing like um, buttons. This also we can take. I will take this button. Okay. There is a notepad. 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 Okay, let's prepare the website first. Now what I will do means I will go into the, now we are inside one particular container, right? I will exit this container. Now I will run another container. So what are the images we have? Sudo docker images. We have only one image, so we can utilize this Ubuntu image only. Sudo docker run container run -it -d -p. Last time we utilized port number 82, right? Now let's take port number 83 and let's map it to port number 80. Name, container name, I will say Gubensland. Okay, and then image name is Ubuntu because we have only one image as of now. Ubuntu. Hit enter, and I will try to get into the container. Sudo docker exec hmm, -it, and then the container name. I'm giving the container name and should be a bash prompt. And then initially what I will do means I will update. I'm inside the container now, guys. You can see, you can feel the difference, right? apt get update. I will update the container to latest. apt get install -y apache 2. I am going to install apache 2. It got installed. Got installed. I will start the service apache 2 start. And then I will put this code file inside vi slash var www html. I will say index 1.html. So I need to install VM, right? apt-get install -y vim. Copy the website. I'll paste this. Okay. Now if I go inside this, we can able to see where www html index.html one. So if we go inside HTML, we can see index.html. Clear the screen. It is there, right? Now what we are going to do is let us check this container. This is a public IP. So this is the previous container we used, right? In port 82. Now what I will do is take the public IP. For this container, we have specified port number 83. We got, right? And then index. Let's check our website. Index1.html. You can see the website, right? The same server. You can see the same IP only. 52, 66, 248, 52. 52, 68, 242, 8, that is port number is 82 in port number 83. So this is the benefit of containerization. This is the benefit of Docker, where in a single virtual machine, that is in single server, you can actually launch multiple application. In port number 82, we have launched one application. In port number 83, you can see we have launched another application with different feature, like with some kind of buttons and all. You can feel the difference, right, guys? Is that interesting, or else you are feeling bored? So this is the main advantage of the containers. Okay, and then uh, so we are almost at the end of the class. So we have seen what is how to install Docker, how to start the service, how to see the version, pull image, Docker container, how to run. We have executed, started, stopped the container, killed the container, removed the container, removed the images, and then next part is Docker Hub. So Docker Hub. So before going into Docker Hub,